Hello students, welcome back. This is your lecture number 2, periodic table. And in the previous video we discussed about your general terms that are related to your periodic table, and those terms now we are going to use in finding out the trends. But before knowing the trend, you should know those points that if I say that metallic nature is increasing, or if I say non-metallic nature is increasing, you should know actually what is metallic nature or what is non-metallic nature. For that you need to watch the video number 1. After that move on to video number 2. Here I will clarify your all doubts regarding your trends. After watching this video you won't have any doubt regarding trends, but before that you have to learn a flow chart. That flow chart should be in your mind. It should be always in your mind when you are dealing with the questions that are based on trends. So from where I got that flow chart, first I will tell you, you have to learn the second flow chart. First flow chart is just to tell you that from where that flow chart has come, which is the main flow chart, but you should know from where it has come. So let's see. So let's take the group number 1. Okay, group number 1 is lithium, sodium, potassium, rubidium, cesium, francium, in this way. If you go to this side, in a period you go lithium, beryllium, in this way up till fluorine you have to remember. After that is neon, and that is a noble gas. Okay. So this is the flow chart number 1, which you don't have to remember. What you have to remember is, see, lithium is metallic. I hope you know lithium is metallic. Then when you are going down, you are watching that metallic nature is increasing. It means more metallic. Metallic nature increasing means more metallic. And when you are going to this side, in a period you are going, what you are observing is non-metallic nature. So this is the thing that you have to remember. When you are going in a period, you should remember that non-metallic nature increases in this way, and when you are going down, the metallic nature increases. Or you can say that if there is a species below another species, it will be more metallic, definitely. And this trend, this is the trend which even is applicable for non-metals. Do not only think that this is applicable for this group number 1. It is applicable for all groups, even for the halogens, fluorine, chlorine, bromine. Okay, so chlorine is more metallic than fluorine, because you know fluorine is most electronegative. Or I can say that bromine is more metallic than chlorine. Why? Because metallic nature is increasing when you move from top to bottom. So this is the flow chart which you should keep in your mind while dealing with these type of questions. If you know this, with the help of this flow chart, now I'm going to tell you all the trends. Okay, so let's start with the trend number 1. The easiest trend that you see in your book, is regarding metallic and non-metallic nature, that I'm not describing. Why? Because no explanation for that. Why? Because already I have shown you that on the basis of this you have to solve everything. So if someone asks you that what is the trend for metallic nature when we move from top to bottom, you have to say that metallic nature increases, definitely. Why? Because this is metallic and the downward species is more metallic. So you will say that on moving from top to bottom, metallic character increases. Now if I talk about non-metallic character, so you can say that since metallic character is increasing, you can say that from top to bottom, non-metallic character decreases. Why? Because metallic is increasing. If metallic character is increasing, definitely it means that non-metallic character is decreasing. Just you have to think about the converse of it. So first trend that is in your book is regarding your metallic nature and non-metallic nature. Now let's move to second trend. Suppose we talk about electronegativity. What will be the trend for electronegativity? Now again you have to look into this flow chart only. This is your main flow chart from where you are going to give every answer. So if I'm talking about electronegativity, first you should know what is electronegativity. That is why I made that video number 1, so that you can clear your concept regarding the terms. Electronegativity is the tendency of an element to attract shared pair of electron towards itself. Now you know that non-metallic charactered species will have more electronegativity, because when they will be placed with the metal, definitely they will be the species which are going to grab the electron, and metals will donate the electron. So if you look into this flow chart again, what you are noticing is, you are noticing that non-metallic character is increasing that direction, or in a period it is increasing. So you will say that left to right. Since non-metallic nature is increasing, it means this electronegativity will also increase. Only this much with the help of this flow chart. Why electronegative character is increasing? Because non-metallic character is increasing. And if I talk about electronegativity from top to bottom, what will be the trend from top to bottom? So see, at the top is metallic, and when you are going down, you are observing that it is getting more and more metallic. More metallic means electropositive character, not electronegative character. Metals are electropositive. More metallic, more electropositive. It means electronegativity will decrease. Electropositive character will increase, but electropositivity will decrease. So what you have to write is electronegativity decreases when you move from top to bottom. Top to bottom, when you are going, the electronegativity will decrease. It will decrease. Okay, why it will decrease? Because downside it's more metallic natured species, and at the top is metallic. And when you're going in a group, then you're noticing that metallic and non-metallic character is increasing. So definitely electronegativity will increase in this way, but electronegativity will decrease when you move from top to bottom. What about electropositivity? Just take the opposite of this. One term, if you know everything about one term, opposite of that will be just the reverse. So electropositivity, left to right, electropositivity decreases. Why? Because non-metallic character is increasing. If a non-metallic character is increasing, it means that electronegativity is increasing. So if electronegativity is increasing, it means electropositivity is decreasing. So for electropositivity, what you have to write is left to right, electropositivity decreases. And what about top to bottom trend? Top to bottom, since electronegativity is decreasing, so electropositivity will increase. It means on moving from top to bottom, electropositive character increases. How you got to know? This flowchart. Make that flowchart somewhere, and whatever trend comes, you have to look onto this flowchart only. Now let's move on to another trend. Suppose we are going to go for ionization potential. Suppose IP. Suppose we want to talk about IP, the trend for IP. Again, what is IP first? IP is ionization potential is the amount of energy which is required to eject an electron from an isolated gaseous atom. This I discussed in the previous video. Why isolated gaseous atom? Why only gaseous state? Everything I discussed. Okay. So first you should know what is IP. On the basis of that, now we have to answer. Now see, if I talk about metals, so what will be their IP? Their IP will be less. It means less IP. According to this flowchart I am writing here. Metals, less IP. Okay. Now you are going to the right side. Right side you have non-metals, more nuclear charge. It means more IP. Instead of non-metal I have written more IP. Instead of metal I have written less IP. Now going down, more metallic means least IP, even less than this. Now your answer is ready, your trend is ready. Ionization potential increases when we go across a period, or when we go from left to right. Okay, sorry, not across a period, across a group. Okay, this is across a group. Across a group, ionization potential will increase. Why increase? Because less nuclear charge, less ionization potential. More nuclear charge, more ionization potential. And this is the most electronegative group, halogen group here. So what will happen? More IP. It means left to right or across a group, ionization potential will increase. But if I talk about top to bottom, if along a period we are talking about, then what will happen? This is less IP and this is least IP, even less than this IP. It means on moving from top to bottom, ionization potential decreases. And I hope you know the answer why we are telling that it's least IP. Because the electron are very far, number of shells are increasing, so electron is very far. The grip of nucleus is not that much tight over that electron, so you need least IP. Here you need less IP, here you need more IP. So your trend is ready with the help of this flow chart. On moving from left to right, IP increases. On moving from top to bottom, IP decreases. Now let us talk about electron affinity. Again, first the definition. Electron affinity is the amount of energy released when an electron is added to an isolated gaseous atom. Now see, this is metal, this is non-metal, and this is more metal, more metallic. Now you should know where it is tough to add an electron. It is tough to add electron in metallic species, and this is more metallic, this is more metallic, and this is metallic, it means the amount of energy that will be released here will be very less that will be in the case of this species. Okay, because it is very tough to add electron in metals, so definitely it will have less electron affinity, it will have least electron affinity, because there is, and the nature of these metals is not to add electron, so least electron affinity. Why? No energy will be released, or negligible energy will be released. We can think like that, because we are forcing a metal to add electron and it is reluctant to add electron because it is a metallic species. So metallic species never add electron, so less electron affinity, least electron affinity. It means if energy is released here, whatever be the energy, so the energy that will be released here will be much less than this. Why? Because this is also metal, reluctant to add electron, and this is more metallic, more reluctant to add electron, and if electron is not added, energy is not released. Okay, so on moving from top to bottom, electron affinity decreases. And what about the trend from left to right? This is non-metal and they are ready to add electron. If something is ready to add electron, then what will happen? Energy is released. How we got to know? From the video number 1. Video number 1, we studied about electron affinity, that whenever electron is added, energy is released. Here electrons are, it's tough to add electrons, so amount of energy released will be less, or we can say negligible in the case of more metallic species. But if you talk about non-metallic species, they are ready to add electron, and if they are ready to add electron, it means definitely energy will be released. So it means electron affinity in this case will increase. Definitely it will increase. Why? Because they are ready to add electron, and whenever electron is added, energy will be released. So we can say that electron affinity from top to bottom decreases. Why? Because metallic nature is increasing, and electron affinity left to right increases. Why? Because chances of adding electron increases. More electronegative, more chances of adding electron, and if electrons are added, energy will be released. So again, on the basis of this chart, we took out the trend for your electron affinity: metallic nature, non-metallic nature, ionization potential, electron affinity, electronegativity, and electropositivity. Every type of question is from this flow chart only. Okay. Now the most important part, which is an exceptional part. Exceptional means the explanation that I am going to give for that is little bit different from here. Okay, the explanation for that is little lengthy, and that is the question, repeated question. Actually, that is the most important part in the trends for atomic radius. For atomic radius, if you are talking about atomic radius, so for left to right it is very easy. Why? Metallic, non-metallic. Now non-metallic have more nuclear charge, reluctant to donate electron, so atomic radius will decrease. Why? Because more nuclear charge, then it will try to have a more firm grip over the electron which is in the valence shell. So what will happen? Size will decrease. Definitely size will increase. Why? Because nucleus is having more power there due to electronegativity. Okay, so definitely when you go from left to right, it is your atomic radius decreases. Why? Because you are moving towards a non-metallic species, so they will have more nuclear charge, so they will try to have a firm grip over the valence shell. So when they have a firm grip over valence shell, the size gets decreased. Okay, now let's move to top to bottom. Metallic, more metallic. Now what will happen? What will happen here? Two cases are to be considered. See, when electron increases, nuclear charge increases. When electron is increasing, nuclear charge will also increase, because as you will notice here, suppose there are 2 shells, after some time there are 3 shells, 4 shells, 5 shells. Shells are increasing. Shells are increasing means electrons are being added there, and whenever electron is added, nuclear charge increases. It means according to the nuclear charge concept, atomic radius should decrease. Atomic radius should decrease according to nuclear charge. Why? Because nuclear charge is increasing because of electrons. But there is also one more factor, that is number of shells. factor number 2. Two factors work here. Nuclear charge increases, size decreases. Number of shell increases, size increases. So there is a confusion here that whether the atomic size will increase or whether the atomic size will decrease, because this nuclear charge is forcing atomic radius to be reduced and number of shell bonds atomic radius to be increased. So what happens here is we have to check which is the dominating factor. The dominating factor here is number of shells. We can simply think that it is among these two, the strongest factor is number of shells. And what is the tendency of number of shells? What effect this number of shells will do? They will increase atomic radius. The number of shell factor want to increase the radius, nuclear charge want to decrease the radius, but the winner here is this one. Dominating factor is number of shells. So what will happen? We have to write overall atomic size increases or atomic radius increases. I'm using a word here overall. Why? Because this will also have its effect. Although it is not dominating there, but it will have its effect, and this will also have its effect. Although this is the dominating factor, but since nuclear charge is also doing its work there, so we have to write the word overall. There is increase in atomic radius. So you have to use the word overall. Why? Because nuclear charge is also doing its work. It is working for reducing the atomic radius. This is working for increasing the atomic radius. Now since this is the dominating factor, so there will be an overall effect. Minus plus, it is just like suppose this is minus 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 by nuclear charge, and it is plus 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 by your number of shells. This is just an example. Okay, so minus 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 plus minus plus. Okay, so what happened? Overall dominating factor number of shell is to be considered here. So overall what we got to know, that number of shell is the winner among the two factors, but you have to mention here that this minus was also doing its work. This is just an example. Do not write this example in your examination. Suppose I'm denoting the effect of this nuclear charge by minus. So this also did its work. What it did, it cancelled many efforts of this dominating factor. This plus also wanted to increase the radius. This also wanted to increase the radius, but it got neutralized by the opposite effect of nuclear charge. Clear? Nuclear charge opposite effect. So that's why I'm writing the word overall. So overall, this is because of what we are getting increasement in radius. Only because of this part we are getting increasement in atomic radius. So we have to use the word overall. So this was the most important trend. Why? Because here you get an exception. Actually it's not an exception. I cannot say it's exception. Means here you have to give more theory. You have to explain. Because examiner can say to you that on moving from top to bottom, there is an increasement in number of electron. Then why atomic radius is increasing? Because if number of electrons is increasing, nuclear charge is also increasing. So it should decrease atomic radius. But what we observe from the trend is that when we move from top to bottom, atomic radius increases. Give a reason for it. So the reason for it is your atomic radius gets increased due to your number of shells. You have to mention there two factors. If you mention only one factor, suppose you are writing there that atomic radius increases because of number of shells. So this is an incomplete answer. This is not a full answer. If you are just mentioning that because of number of shell, increasement in number of shell, atomic radius increases, so that is half answer. That is not fully correct answer. You have to mention the two effect. After the two effect you have shown there, you have to show that this is not the dominating factor. The dominating factor here is number of shells. So overall there is an increasement in the atomic radius. So in this video what we discussed is, we discussed the trends about your first metallic nature, non-metallic nature, then we talked about electronegative character, electropositive character, then your ionization potential, electron affinity, and last we discussed about atomic radius. Why I took this topic in the last? Because of this, because there was much to explain about your atomic radius trend. So I hope you would have got enough clarification regarding the trends. Okay, and if still you have some questions, you can post your comments. Okay, so till then, keep going, keep studying. Thank you.